Turn out of the way here. Good afternoon, everybody. Welcome to the Headwaters Science Center. My name is Ryan, and I'm one of the educators here at HSC. And if you guys have been following us for a while online, you know that it is 3:30, which must mean it is time for one of our after-school STEM shows. We've been doing these every single day at 3:30, going live on Twitch and Facebook, and recently we've added YouTube into the mix, so you can go and catch us live on any of those platforms. Every single day at 3:30, we're probably getting pretty close to day 100 at this point that we've been doing it consecutively, so it's been a good streak for us. And basically what we do is we go live for 15, 20, 30, sometimes when I'm around an hour, minutes, kind of talking about different science-y topics here. And today we have a very interesting one that I'm sure a lot of you have seen online before. We're going to be doing that classic Mentos and Diet Coke experiment. Like I said, this is one that I'm sure you've seen online before, but maybe you haven't gotten really an explanation as to why that happens. And so what the expected result here is, not to spoil it for everybody, but basically you take a Mentos candy, one of these guys, you drop it into a bottle of Diet Coke, and you get the spectacular fountain of Coke that shoots out. Like I said, one that's been around as sort of a cool video, sciencey video that you see online for years and years and years and years at this point, but like I said, you very rarely actually get any explanation for why it's happening. Have any of you ever looked it up or thought about why that happens? When you drop the Mentos in the Coke, you get the big fountain? Have any of you ever thought about it? Or even learned about it? Do any of you know? You do my job for me? Yep.
I always dream about drinking it.
Yeah. I like to drink it too. I do it in moderation. I'm not a huge pop drinker, but I do like to drink a Coke every once in a while. This is not sponsored by Coke, by the way. But anyone else? Anyone else ever, I'm sure most of you have seen this experiment, right? Nods all across the board here. Yeah. But like I said, not the most common thing to know why. And so when we're talking about why this happens, there's one word that you need to know, and that is nucleation. So that's Nucleation. If I'm wrong, tell me in the comments. Nucleation. And there's a part of that word that I'm sure a lot of you know. I'm sure a lot of you know the word nucleus. Is that a word that you guys have all heard? Nucleus? And so what's a nucleus? Any of our high schoolers gone through biology yet? Want to explain?
The center of an atom.
A nucleus is the center of an atom, is what we got from the back row over there. And that's true. So when you are in an atom, or looking at an atom, it's kind of got a couple different parts to it. So you'll see there's this kind of middle part that is made up of what we would call protons, which are positively charged little particles, and neutrons, which are neutrally charged little particles. And that is the nucleus. And electrons are the negatively charged part of an atom, and they kind of swirl around the outside of a nucleus. And so the nucleus is where you get the mass of your atom. And it's the positively charged point. So it's in the middle of an atom is the nucleus. Have any of you ever heard nucleus used any other ways? Yes?
I think it's because the nucleus rise up so the nucleus can be free.
Happens because the nucleus can rise up and be free. I like it. And I like that hypothesis, and it might have some merit to it. We'll talk about that a little bit later. But me, most of my background is in biology, so I tend not to think about, when I hear the word nucleus, I usually don't think about that term, the one Savannah in the back row came up with, the part that's in an atom. When I hear nucleus, a lot of times I tend to think of a cell nucleus. And so this is something that, again, if you take 7th, 10th grade biology, whatever, you'll encounter this, is that within cells of living things, within human and plant cells, there's these little things in them called organelles. So they're kind of like our organs, but just way smaller because they're packed into this little teeny tiny little cell. And the nucleus is one of those organelles. It's kind of, I don't love this to think of it this way, but it's kind of like the brain of the nucleus, or the brain of the cell. It's kind of the middle core component of it. And so similarly to how the nucleus of an atom is the middle, the nucleus of a cell is kind of the middle too. And so nucleus has some specific uses within science, but it also in the broader sense means just kind of like a core, like a centerpiece that other stuff builds upon is what a nucleus is. And so, like I said, the process that we're going to be talking about today a little bit is nucleation. And so you can think of nucleation as sort of like the process of creating a nucleus is sort of how this is going to work. And so, I think, with no further ado, we'll try with one of these. and see how this is going to work. And you'll notice I have a few different beverages here that we're gonna try. And I have with me just some standard everyday Mentos. And I gotta say, personally, I have never done this experiment before, so I do not know what the splash zone is gonna be. So if y'all get wet, I'm sorry. And if I get our recording equipment wet, I'm sorry to the budget of the Science Center. But I think we'll start out. Let's start out with the classic, the Diet Coke, the one that you usually see in these. And so I've my high-tech chamber I've created here to contain our splash, this tote on its side. So I've cracked the top, and I'm seeing some bubbles happen right away up top. Let's do some observing while we go in there. And I have a Mentos that I just pulled out there too, and I'm just going to drop it right inside here, and we'll see exactly what happens. And we are getting not a super crazy fountain, but you are seeing all of a sudden a lot of the pop is suddenly leaving our bottle here. And I'm glad that it's not a crazy fountain, to be honest, because I did not want to make my volunteers have to do all that mopping. But what we saw there was, this is, we lost maybe half of our pop there out of the bottle, all left, when we dropped that one little teeny tiny, nickel-sized Mentos in there. So it's not just a matter of, this displaced just by virtue of being in there. Like, it's not like I just put that much volume of stuff in there and it displaced all that Coke. Some sort of reaction happened there that forced more out than what was actually, forced more out than what I put in. I said a nucleation is that process. Maybe I can even get away with using a little smaller something here. And don't have anything handy, don't worry about it. And so, do we have any hypotheses as to why that might have happened? Any thoughts? Are we thinking, yeah, you on the left.
It maybe could have been because it was Diet Coke.
So, happened because it was Diet Coke, so do you want to try it with the regular Coke? And if we try it with the regular Coke, do we think we're going to get a different result now? Yes, so she thinks we're going to get a different result with regular Coke, so remember that hypothesis. Yep.
Well, the Diet Coke, it's the Diet Coke because it's called Diet Coke because it's diet.
So she said the Diet Coke is different than the regular Coke. There's an element there that's a little different. It's Diet Coke, and maybe that has some implications for what's inside here that's going to be different in the back. So she said she wants to see what happens with different amounts of Mentos, which is a good question to have. If I had a little more budget for this, I might have bought a few more bottles of the same types of pops so we could test the same pops with different amounts of Mentos. I did think about that, but maybe that's something we can test out here, maybe once we get to our other ones. But we'll take a look at our Coke, since we had a hypothesis that the Coke is going to react different than the Diet Coke for some reason.
So, bigger, smaller. Bigger.
Think the regular Coke's going to be bigger?
Bigger fountain.
Bigger fountain on the regular Coke?
I think it's going to be this.
Coke is going to be bigger.
Oh, and what'll be interesting is we can actually see how much it forces out by, once we settle here, we can see how much is left. Nope.
I think this deserves a drum roll. Do you know how to do a drum roll?
Yeah, drum roll.
Ready?
Alright. I don't know when a drum roll stops.
Stop when the Mentos was in here.
A little bit. Seems like it's maybe going longer than the other one, but we don't have the same spectacle right off the bat, seemingly.
Bigger, smaller. Bigger, smaller. Which was it? Bigger, smaller, bigger, smaller, bigger, smaller. Ready? It's like, what was it?
Small.
Smaller. Coke was smaller.
Yeah, like I said, we can see how much comes out if we take our labels off.
There's a guy in the back that's giving you all kinds of hand signals.
Was one of them colder than the other?
I did not take the temperatures of them, but they were purchased at the same time and were in the same grocery bag right up until before the show. So probably not drastically so.
Okay.
But what we are seeing is a little bit less Diet Coke left in the bottle than there is regular Coke. So yeah, you're right. There's a little bit less was displaced there. So now the question is, of course, why? You have some insight for us?
It's why. It's because
So yeah, there is a difference. Something is different between the Coke and the Diet Coke. And something about the Coke being different than the Diet Coke is resulting in a different outcome as far as when we drop Mentos in there. And so, I guess we'll kind of give up the ghost on this. I know the answers, of course. And so one of the big differences between Diet Coke and regular Coke is the sweetener that is used in it. And so Diet Coke uses a sweetener called aspartame, whereas regular Coke uses high fructose corn syrup, which is it sucrose? That's the core sugar in that? I don't remember. Doesn't matter. But what you're seeing is one of the big things that's going to affect us is how much CO2 is in there. So all the bubblies that are in the water, that's all CO2 that's dissolved in the liquid.
And CO2 is what?
Carbon dioxide is CO2.
Carbon dioxide.
Carbon dioxide. Surrounded by it all the time, you exhale it, CO2. And so that's what makes these things bubbly, is there's CO2 that's put in them. That's what carbonation is. That's why it's called carbonation, because it's carbon dioxide. And so what happens when you drop a Mentos in is all of a sudden, you know, you wouldn't necessarily know it from looking at a Mentos. If you look real close at it, it looks mostly kind of smooth. But if you look real close at it, you know, if you were to look at this under a microscope, it's actually covered in all sorts of little teeny tiny little pits, little bumps. You know, when you look at them under a microscope, they almost look like a golf ball. And so what all those little pits and bumps do is give it a lot of surface area. And so what's happening when you drop a Mentos into a bottle of Coke, Diet Coke, any sort of carbonated beverage, is, like I said, nucleation happens. And nucleation, to make nucleation work, all that, what's happening is that CO2 is going from being in its dissolved state to very suddenly, very rapidly turning into its gaseous state. And so that gaseous state takes up a lot more space than the dissolved state does. But in order for that to work, it kind of needs something to hold on to. And so you can see this like every day when you are, you know, if you can just pour some out in a glass, you know how the bubbles kind of stick to the side of your glass. They don't just, there's not just bubbles just like floating around in your cup generally. They kind of stick to the sides. They want something to kind of glom onto, and that's what facilitates that, that nucleation to happen. And so because these are so rough and so bumpy, they allow for a lot of CO2 to glom onto it really quickly. And so that's why you all of a sudden see all this CO2 that's like, oh, I'm here, I gotta get out. And it just takes all this pop with it. And so the biggest thing that's gonna affect how much comes out is how much CO2, so how fizzy the pop is. A fizzier pop is gonna result in a more spectacular fountain. But also the amount of sugar has a little bit of an impact on it as well. And so that's why you tend to see the diet pops work a little bit better than the non-diet pops. And the big thing that the sugar affects is the surface tension of the liquid. And so surface tension is sort of the tendency for liquids to sort of, I guess, glom onto each other, I guess would be sort of a way you can think about it. And you want less surface tension to get a lot of spectacle in this. So having sugar raises the surface tension of a liquid in a way that having aspartame doesn't, which is why the diets work a little bit better. And so that result is exactly what I was expecting to get. But I still have 3 more cups here. I'm just gonna eat this one.
If you come to work here at the Science Center, you can eat a Mentos whenever you feel like it.
Mm-hmm. I love doing cryo because I get a free banana out of it most of the time. Now, what I have here is a cup, a little clear cup, and what do I have in there?
Yes. What is it?
Thoughts? What's that look like to you?
I know what it is, but I just forgot what it's called.
Classic.
Me too.
This is sand.
Sand.
And why do you suppose I have some sand in a cup? Like I said, we just talked a lot about a Mentos and how the reason that this thing works is that you're very suddenly adding just a bunch of surface area into your beverage, and all it gives an opportunity for that CO2 to nucleate out. I don't know if that's the way you would phrase that, but something for that CO2 to glom onto and very suddenly take up a whole lot more space than it used to. And so, like I said, a lot of people assume that with the Mentos, it's like some sort of chemical reaction that's happening, but it's really a physical one. It's very, very dependent on just like that property of the Mentos, like what its texture is like on the outside. And so what I think I want to try is something else that just is kind of similar, has a lot of texture to it. Is going to be suddenly a lot of surface area in there for all the stuff to glom onto. And I expect that if I try this with sand, we're going to get a similar result, if my hypothesis is correct.
Did you ever drum roll this time?
Nah, we did it once. And we're trying a different pop this time, so this is kind of bad science. If we wanted to really, really know what's the difference here, we would be doing it with the same type of pop every time, but we're using what we got, so it goes. We'll pour some sand into. This is a Sprite. Again, not sponsored. We lost a little bit, but there you go. You're seeing maybe not quite the same spectacle that the Mentos had, but you are seeing a little bit of that same type of thing happening, where there's definitely more Sprite leaving that bottle than there was sand that I poured in. And seemingly it's done. And so this works with pretty much anything. Like, you can put any old thing into a bottle of carbonated beverage and you're going to get a similar result. This is also why like shaking a drink causes it to expand very rapidly, is you're suddenly creating an environment where there's a lot more bubbles, there's a lot more stuff getting kicked around, turned around in there. And so when you crack it open, all of a sudden it's like, oop, pressure release, all the CO2 can suddenly get big and escape really quickly. Same deal, same thing that's happening. Another really cool experiment that you could try at home that has to do with nucleation would be supercooling stuff. And so obviously the most common thing to do that with what is water. And so supercooling is the process of taking something and getting it below its freezing point without it freezing. And so, like I said, the most common thing that you'll see this done with water, and you won't be able to just do this with your tap water. You're going to have to get some purified water. I've seen it done with just like a bottle of Fiji water. Not sponsored. But if you have any other way of having some sort of reverse osmosis, deionized water, it should work. And so basically all you do is you take it and you throw it in your freezer and you let it get cold, you let it get cold, you let it get cold, but you got to be very careful to not disturb that bottle too much. So you just sit there and let it get cold and stay still, and get cold and stay still, and get cold and stay still until it gets below its freezing point. And like I said, you'll look in there and you'll see, and it's been sitting in the freezer for 3 days and it is still liquid. And so when you, but then when you take it out and move it, you know, you can be, sometimes you got to be a little rough with it depending on how far below the freezing point it is. But if you get it cold enough, you know, you take it out and as soon as you just give it a little wiggle, the whole bottle will freeze at once. And basically what's happening there is the same type of reaction. It's a rapid nucleation that's happening where basically you're creating a bunch of bubbles all of a sudden for that, for the ice crystals to freeze on. So the ice crystals are basically doing what the CO2 is doing. And so the ice needs a thing to work, a thing to start growing on. And so shaking the water creates bubbles, which is what does it. And so like I said, that's an experiment you guys can do at home without having to worry about making too big of a mess, dumping pop all over the place. Yep.
If we still have leftovers, can we get a couple Mentos in each cup?
Yeah, I think that's what we're going to try and do with these last two since we had the experiment. And we've established that the sugar matters a little bit, and Sprite is interesting because it apparently has 0 sugar. And then we have some tonic water here, which, I don't know, never tried it with tonic water. Never really seen it done. I know that like the appeal of the tonic water is that when you do it under a black light, it looks kind of weird. Again, never done it, but we don't have a black light here handy. So what do you say? Let's try. I got most of a roll of Mentos left. Had my grimy little hands all over it, so I don't know if we're gonna do anything with these. But let's try our sugar-free Sprite, and we'll throw 5 of them in there. Yeah, what's up?
I was thinking at the end of this, maybe we could have salad.
You want to drink some of it? Is that what I don't know if you're gonna want to drink these. Whoop.
Oh, no.
That one's already going off before we even put anything in there. So we've lost a little bit already. So document that in our notes we're taking about these experiments. We lost a little bit just in.
We're putting 5 in.
Yep.
Is there any chance we should move back?
I don't know. We put 3 in. I couldn't get the other 2.
We use the other 2 for another pot.
See if we can put 2 more in and see if we can get it to happen again. Or did all the CO2 leave?
I'll drink it.
So it's not happening again even though I put 2 more in. So what that tells us is there's not a whole lot of dissolved CO2 left in there. At least not enough to make it rise up out. But you'll see. We lost quite a bit more on that one, so we put more Mentos in, we lost more pop. And let's see. We'll use up the last of the roll in the tonic water, just for funsies. Because the rest of this hasn't been fun, right? So this is the fun one.
It looks to me like this might have slightly more of whatever the liquid is in it.
Yeah, this looks like a bigger bottle.
That could affect it as well.
Yeah. So this is a liter bottle, whereas the rest of them have been 20-ounce bottles. So a little over half a liter. Oh. That was a little shaken up too. I said we got these from the grocery store right before we started today, so maybe we got a little shaken up in transit.
Adios, amigos.
Alright. A little bit bigger bottle. See if I can get them all in there at once this time so they don't force their way out. Theoretically, the longer I leave this bottle open, the less effective this will be too, because that CO2 is escaping as it goes. That's what's happening when your pop goes flat. Alright. A little bit more that time. A little bit more liquid, but we actually got 4 of them in there. The 5th one didn't quite make it. But don't suppose anyone wants to try that, do they?
Yeah.
Couple, 4 or 5 different liquids, Mentos, and probably a little sand. But alright. Like I said, one of the most common experiments you'll see people doing around on YouTube is kind of a fun thing to do at home. So I hope next time you see that, you'll have a little bit better understanding of how that works. Like I said, you can try that supercooling experiment at home. I know that was one that my 9th grade teacher did that I remember to this day, him doing that and thinking it was really cool. So something that might be an interesting one for all of our viewers out there to try at home themselves. But otherwise, thank you all for coming in and watching. Thank you to our audience for participating. I love being able to throw out questions there and get some answers. And we are going live every day at 3:30, remember, so you can check us out at twitch.tv/Headwaters Science Center, facebook.com/HeadwatersScienceCTR, and youtube.com/Headwaters Science Center. You can watch us live in any of those places.